Okay, this is 4.3, and it's how to factor a quadratic. If you'll remember, we've already talked about how to FOIL a quadratic to get back to the standard form. So this is how to go from this backwards. Okay, first let's talk about signs. Inside the two factors, if both of the signs are positive, then it will turn out to be all the signs inside here will be positive. So if you see this, you need to put 2 plus signs. If you start with a negative and a positive here, then both of the signs inside the parentheses will both be negative. Okay. Now, if you have a positive here, and then this sign is either a positive or a negative, that means that one of these is negative and the other, if this is negative, then one of those is either negative and one is positive. Okay? And we need to put the sign that's here with the greater value of this number. Say we knew that 1 was 4 and 1 was 6. Then if this sign here was positive, I would put the 6 here and the 4 here. But if this sign was negative, then I would flip them because the 6 is bigger. So it needs to go with the sign that is right here. Okay. You'll get a feel for these, so don't worry too much if you're going, what? You'll get faster as you go along. Okay, let's do some of these. Okay, x squared minus 3x minus 18. I'm going to go ahead and put a 1 here, even though you usually don't see it, because I'm going to talk to you about a trick. So a trick is to take this number and completely factor it. So remember the factors of 18. I can say 1 times 18, 2 times 9, or 3 times 6. And then if I put them over the factor of the leading coefficient, which is just 1, then all these numbers would really turn out to be just themselves, right? Still leaving us with 1, 2, 3, 6, 9, or 18. What that helps is that these numbers inside of here has to be those, one pair of those. So let's look at my sign. I have a negative here, and the only way to get a negative is with a negative and a positive. And then I have a negative here, so that means my greater number will be with my negative sign. Okay. What are 2 numbers out of this set of numbers that can multiply together to get 18, But when I add them, or subtract them actually, I'm going to get 3. So 6 and 3 are the only ones that match that criteria. So I'm going to put my greater number, the 6, with the minus sign. And I'm going to put my 3 on the other spot. The only way to get x squared is x times x. And that's my factored form of this quadratic. Now to check, I can always FOIL or do a Punnett square back. X squared minus 6x plus 3x minus 18. This would be minus 3x. So you can see that I have exactly this back. So I did it right. Okay, let's try another one. Okay, let's go ahead and use our trick. I'm going to factor 20. So 1 times 20, 2 times 10, 4 times 5. And I'm going to put them all over the factors of here. So this is just a 1. So it's really not going to change my list any. So put my 2 parentheses. I have a positive sign here and a negative sign here. That means they're both going to be negatives. Okay. What 2 numbers out of this list multiplies together to get 20, but when I add them together, they're going to get 9, 4, and 5. Since both my signs are negative, it doesn't matter where I put them. And there I go. Okay, here's one with 2 positive signs, or my factors of 5. This is going to be really easy because I only have 1 times 5. So inside, if I have 2 positive signs, that means they're both positive, and it has to be 1 and 5. Okay, here's one with a positive and a negative. So let's factor out 40. 1 times 40, 2 times 20, 4 times 10, 5 times 8. So, only way to get a negative on the end is negative and a positive. I have a positive in the middle. That means I want my bigger number over here with the positive sign. What 2 numbers multiply together to get 40, but when you subtract them, they get 3, 5, and 8. So it's this. So can you see that after a while these become just really fast for you? And I promise you that you'll get there too. Now, there's a couple special factoring situations. So let's look at that. If we have 2 numbers with a minus sign between them, and they're both squares, perfect squares, that will always turn out to be the square root of the first one and then the square root of the second one with a plus and minus between them. That's the only way that this middle term, because you know that I really have a 0x in the middle, that middle term will drop out. Because when I fold this back, it'll be x squared plus 2x minus 2x minus 4. So the middle term drops out when one is positive and one is negative. Beware of the fact that if you have a plus sign here, this cannot be factored. And for you to understand why it can't be factored, we need to go back to the graph of this. So let's go ahead and get a clean space and say x squared plus 4. Let's go ahead and graph this. My line of symmetry is negative b over 2a. Where's my b here? Well, I don't have a b term because remember the b term is in front of the plane x, so it's 0. And then my a is 1. And so my x term of the vertex is 0. And my line of symmetry is 0. So to find the y term of the vertex, I put the 0 back in. And I solve. So my y is 0. So my vertex is at 0, 4. So let's put it about right there. Now, is this open up or down? This is positive, the a is positive, so it's going to open up somehow. Notice that, remember when I have the 2 parentheses? Something like this. This is actually giving me the x-intercepts. So this one would cross at -1 and -7 over here. So if I graphed it, it would be something like that. Does this graph ever cross the x-line? No. So it doesn't have any x-intercepts, which means that I cannot put it in intercept form. Or another way to say it is it cannot be factored. Now, that's actually a pretty simplistic answer. I can actually factor this, and we will pretty soon. It just can't be factored with real numbers. That's where those elusive imaginary numbers come in. So, let me give you another one that can't be factored. Okay. If I was just looking at this and I didn't know it could be factored, I would start out by thinking about the factors for 9. 1 times 9, 3 times 3. And then I would say positive. The only way to get a positive here and a negative here is for both of these to be negative. So out of here, what 2 numbers can I put in that would multiply together to get 9, but add together to get 3? So if I put 1 and 9, that would leave me with -10 on the inside, and that's not 3. If I put 3 and 3 here, that would leave me with -6 on the inside, and that's still not 3. So there is no way to factor that. If you get in this situation and you think, I don't think this can be factored, but I'm not quite sure, do a quick graph on your calculator. If it doesn't cross the x-axis, you know it can't be factored. If it does cross the x-axis, then you know you've done something wrong, or you just need to look harder for the factors. Another special pattern that comes up that's maybe not quite as important as the difference between 2 squares is something we call a perfect square trinomial. And it's something like y plus 10y plus not 20, 25. So if we start playing around with that, 25 can be 1 times 25 or 5 times 5, right? So which ones can I multiply to get 25, add together to get 5? So of course they would be both 5, or add together to get 10. So they're both 5. Now, you'll see that if you take the square root of that number, and then if you multiply by 2 and get this number, it'll turn out to be one of these factors that have the exact same factors. So, what's another easy number just takes the square root of? Let's say 100. What's the square root of 100? 10. What's 2 times 10? 20. So that would be y plus 10, y plus 10. Now, a lot of times when you see this, they'll go ahead to save room and write that as a single factor squared. And then I'm going to say this again. I know I've said it before, but it's really important that you know not to just bring in this 2 and say it is y squared plus 25. And that's not right, because we know that that couldn't be factored. So it is, it comes back to this. Okay, this is also a pattern that we could use with a minus sign here. And then if we put a minus sign there, these both would just be negatives. Okay, so when you see those words factor the quadratic, that's what they want you to do. They want you to put in the 2 parentheses. But we can take that a step farther, and there's several different ways they can ask you to take it a step farther. They could say find the roots. They could say find the x-intercepts. They could say solve the quadratic. And they could also say find the zeros. Okay, so there's a lot of different ways to tell you directions to find the next part. But all these ways, all these sayings, are really telling you to do just one thing. So, let's take something that we've already factored. Oh, let's change this to x. And then use one of these directions up here. So find the roots of this. So we factor it first, and then what we do is set this y to equal 0. So we're looking for the x-intercepts. Now, remember, if I tell you that some multiplication fact, a times b equals 0, you can't for sure tell me what a is or b is, but you can tell me that either of them has to equal 0. Because the only way I can multiply 2 numbers together and get 0 is for one of them to be 0. So let's assume that this first factor is 0. then what number could I put in for x to make that 0? So I find that just by setting that term to equal 0 and solving for x. So x equals 5. Since I have the same term over here, if I set this one to equal 0, I'll get the same thing. So the roots of this equation, or the x-intercepts, or to solve it, or to find the zeros, this would be 5. What does that mean? That means if I graph this quadratic at x equals 5, it would just touch that line at that point. Let's try another one. So if we have x squared plus 9x minus 36, and I'm going to tell you to solve this expression. Okay, so remember when I say solve it, all I'm doing is asking for the x-intercepts. So I want to go ahead and factor this using our trick where are all the factors of 36. 1 and 36, 2 and 18, 3 and 12, 4 and 9. So, what two numbers could I put in that would multiply to get 36, but then subtract to get 9? Okay, and I haven't explained this to you before. Sometimes I say add to get 9, and sometimes I say subtract to get 9. So if the signs are opposite, I know I need to subtract. So out of here, what two would do that? 12 and 3. I have a plus here, so that means my bigger number needs to go with the plus. And there's a factored form. But that's not all the directions. I said to solve this. So now we need to say either x plus 12 equals 0 or x minus 3 equals 0. So I'm going to solve these two. Minus 12 for both sides, or add 3 to both sides. That means my solutions are 3 and negative 12. So again, if I graph this, it would go through the point 3 and negative 12. So I have some sort of graph like that. Okay, before we close, let's talk about one type of story problem that I can have on these. And those are the area problems. If I have a trapezoid and the base is x plus 6 and x plus 2, and then let's say my height is x. And I know this whole area of my trapezoid is 4. Let me find the value of x. Well, first I need to write the area formula. Remember from geometry how to find the area of a trapezoid? It's the average of the two bases. So I add the two bases together. I need to divide by 2. What that really gets us is this line right here. And then I need to multiply by the height. And that should equal the area. So let me go ahead and do that. So adding these two bases together, x plus x gives me 2x. 2 plus 6 gives me 8. I'm going to divide by 2, multiply by x. So if I divide by 2 here, what I'm really doing is splitting these fractions up with 2 underneath them to say that is really x times 2x over 2 plus 8 over 2. Okay. A common mistake is to try to cross this out here and this out and just leave the 8. But I can't do that. I have to divide both of the terms by 2. So this will be x times x plus 4, which is x squared plus 4x. X. And then we still know that equals 4. Okay, so that's a little hard to solve right now. So let's subtract the 4. X squared plus 4x minus 4 equals 0. Now it's in our quadratic form. Let's go ahead and factor it out to get, let me see if I can move this whole thing over a little bit. There we go. Let's factor it out. So I'm going to rewrite it, x squared plus 4x minus 4, where all the factors of 4, 1, 2, 4, minus here is plus and minus. My big number goes with my positive. What two numbers can I multiply to get together to 4? But add together. Whoops. I have messed this up because there are no numbers that. So I've just looked at the problem again and I have written the problem down wrong. So let's go back and correct my mistake. So the area should be 32. 32. So this would be minus 32 here, which changes all this. Okay, what two numbers multiply together to get 32? But then when you subtract them, you get 4. That would be 8 and 4. So my big number has to go with my positive, 8. My small number with my negative 4. So all that's going to equal 0. Now I need to find the solutions to this. So x plus 8 equals 0. So x is either equal to negative 8 or x minus 4 equals 0. X is either equal to positive 4. Now looking again at my trapezoid figure, I had an x here. Could I ever have a negative number for a distance? No. So I drop out the negative answer because it's an extraneous solution. It seems to be correct, but it doesn't fit the story problem. So I know now that my x is 4. If I wanted to solve for my other side, x plus 6 on top, that would equal 10. And my bottom would be x plus 2. So 4 plus 2 equals 6. Okay. So if you are, it's kind of long, so let's go through the steps again. If you have an area problem, first write down the area formula. Substitute the sides in for the length and the width, or the bases, and then set the area to equal the number they tell you to equal. Multiply everything out, move everything to one side, factor it, and then get rid of your negative answer.